Alright, this is day 7 in Algebra 2. So today we're going to take another day on the properties of exponents. Basic skills that you've learned in pre-algebra, you should have done them in algebra. These are like basic, and we want to know the properties real well because this is like basic structure, like skills that you need to do. It's kind of like a football player in high school. A football player in high school needs to know some basic stuff. They need to like be able to run. They need to know how to hold the ball, right? They need to turn their head, right? What else? Basic stuff they need to do. They need to have some strength, right? So I know that's silly, but these are the basic things. You need to know how to do exponents, basic stuff, okay? So if you're on the video, you're on the same steps as yesterday. If you want to pause the video, you can write these down. If you don't, if you're in class, you just have the same thing, okay? And here we go. I want you to make another one of these in your notes. I'm not going to pass this out. And it doesn't need to take a whole sheet of paper. You could just take like part of your notes, make a big square, put an oval in the middle, make some lines to make some boxes, and put exponential properties in the middle. And the titles here, again, are different today. There's negative exponents, power property again, and then a to the first power on the bottom right. Okay, I'll give you a minute to write this. Okay, so in each box I'm going to show you what it means. I'm going to give you an example. You're just watching, and then when we're done watching, you're going to talk in your group, and then you're going to write it down. So no writing right now, pencils down. So the first thing is negative exponents. Okay, so negative exponents. Let's say you have anything to the negative power. In math, for now, we do not like the negative exponents in Algebra 2. It just doesn't look right. Okay, so the way we deal with that, n to the negative first power, we could think of it this way. We could say it's n to the negative first over 1, right? Do you all agree that we can make anything a fraction by putting it over 1? Yeah? So we don't like a negative power, so the way we get rid of it is you just take the term wherever it's at, numerator or denominator. So in this case, n to the negative first power, the exponent's in the numerator. Just take the base and the exponent, and instead of it being negative, we're going to switch the side, put it in the opposite. So in this case, it's the denominator. And we're going to change it to positive, so it's going to be 1 over n to the first power. Okay? That's the rule. Let me tell you why now, okay? So, or here's another example. Okay, the opposite's also true. Let's say you had a negative exponent in the front or in the bottom. Okay, we don't like a negative exponent. Just move the where it's at. Just put it, instead of in the bottom, you're going to put it on the top. N to the positive first. Okay? So, n to the positive first is just n. Okay? Does that make sense? Here's why. Remember last night, some of you were working on your like quotient property. Remember yesterday we had like n squared divided by n to the third. Remember this? Eyes up here. N squared divided by n to the third. We could cancel n squared out and 1 from the bottom, leaving 1 on the bottom, so it's n to the first. Why does that work? What if I rewrote this original problem here as n squared divided by n to the third? What would I do with my exponents? Good, so what's 2 minus 3? Negative 1, right? So if n to the negative 1 should be 1 over n to the first, and this is why the rule works. Does that make sense? If this is the same as this, then we could just assume when we have n to the negative 1, we just write it like this. Does that make sense? Okay, so let's have all the fours. Let's start with fours. Fours, raise your hand. Fours. Okay, fours are talking to the rest of the group, explaining the rule and explaining why it works, and then you can write this down. Ready, set, go. Power property. Okay, so the second one, power property. So we learned the power property yesterday. What if it looked like this? What if you had a problem like this? Like it looked like it was in a fraction. Okay, n squared over n cubed. And then you had a power on the outside. Okay, eyes up here, pencils down. If it looked like this, here's the rule. If you have a fraction with exponents on the inside of the numerator and denominator and it was being raised by it, just do what you did yesterday. You just multiply the exponents. So n squared to the third is going to be n to the sixth. Or we just multiply 2 times 3, right? N to the 3 raised to the third is just like n to the 3 times 3. Multiply it out, you get n to the sixth over n to the ninth. Does that make sense? I know I could simplify this some more, but that's the property, okay? So, 3s. Raise your hand. All the 3s in the house. Good. 3s are talking to the rest of the group about the power property example we have here. Ready, set, go. Here we go. Power property again. Here's another example. Eyes up here, pencils down. Pencils down. Third example. So let's say you had 3n squared times 3m, or times m cubed. And all of that was being raised to the second power, okay? Right? We're going to multiply each exponent by this outside exponent. So this 3, okay, so this 3, I want you to see this. This is a little trick. Any number has an imaginary exponent above it. So this 3 has a power of 3 to the 1. Because I know that 3 to the 1 is still 3, right? Do y'all agree? Yeah. So we're going to take this outside exponent. I don't even know why we're still talking over there. What? Warning, okay? Okay, eyes up here. So we have 3 to the first. We're going to raise it to the second. So we have to multiply. So we got 3 times 1 times 2. Then we have n squared raised to the second. We're going to multiply that also by 2. And then we got m cubed. We're going to multiply that by 2. Make sense? Okay, then we're just going to multiply it out. We got 3 times 1 times 3 to the 1 times 2 is 3 squared. N times 2 is n to the 4th, and m is to the 6th. Simplify. What's 3 squared? 9. So then this is what your answer should be on this example. Does that make sense? Okay, good. So 2's, raise your hand in each group. 2's, 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 2's. Okay, explain this example here. Ready, go. So we got a to the first. A to the first is equal to a, because I want you to know that anything to the first power is itself. Anything to the first power is itself. So what's a to the first? A. Good. So what's a to the 0?
1.
Good. 1. What's a to the 0?
1.
Good. So if I give you a long problem like 1,238,546,000 to the 0 power? 1. Good. Got it. I like that. So slow down. Don't just put 0 or 1. What is 1 billion to the first power?
1 billion.
1 billion to the first power. Slow down.
1 billion.
1 billion. Someone said 1. Okay. 1 billion to the 0 power?
1.
1. Okay. There are differences there. Good. Turn to your neighbor really quick. Let's have one. Tell the rest of the group anything to the first power of the rule. These are the basic extra properties. These were already introduced to you way before. I just want to make sure you got the idea. These are the basic rules. Here we go. So now we're going to go. Numbers 1 and 2. Watch up here. These are the hardest kinds of problems you'll face in today's homework. But these will show all the skills, okay? So number 1, we want to simplify this. There's a bunch of exponents everywhere, right? So the big idea is to work in sections or chunks and then work on the bigger problem, okay? So on this problem, I'm just going to focus on the top, okay? So I'm going to cover the denominator because I want to just focus on the top. On the top, I'm noticing there's a 2, a cubed, b to the negative second, all raised to the second. So I know that 2 is like saying it's to the first power. So 2 squared, we're going to bring that down. 2 squared is 4, right? A to the third is like to the raised to the second power is going to be a to the 6th, right? B to the negative 2 power raised to the second power is going to be b to the negative 4 power. Does that make sense so far? And then I remembered I covered the bottom of the original problem, which is the denominator. I want to bring that back. I'm bringing it back down to my problem. Okay, I'm not going to do anything. Now I could start working this out a little bit more. I noticed that I could that I have this b to the negative 4th power. I'm going to bring that down to the bottom. You see how there's that b to the negative 4th power? I'm just going to bring it down here. You see that? Because do we like negative exponents?
No.
No, we don't. Okay, now we're simplifying it some more. Now I'm noticing I could combine or simplify or cancel out some of these exponents. So this 6 turns into a 2 when I take out this 4, right? A to the 4th, right? Which leaves 4a squared in the numerator. And then this b cubed times b to the 4th is b to the 7th power. And then we're done. Okay? So that's how you do number 1. Okay? Again, big idea here is work in chunks. I covered the numerator. I know that this 2 needs to distribute to each of these terms. 2 squared is 4. A cubed squared is a to the 6th. B to the negative 2 raised to the second is b to the negative 4th. All over a to the 4th, b to the 3 in the denominator. Then I start simplifying. I know that's b to the negative 4th I could put in the denominator here. Brought all the rest of the problem down. Simplified the a's. The b's I combined together has got b to the 7th power. Okay? That's number 1. Watch me do number 2 before you write. Or before you talk, actually. Okay, pencils down still. Number 2, same idea. I'm going to cover the denominator because I think I'm going to focus on that numerator first. The numerator has some things I could work on. So First thing I could do, I notice it's 2x cubed, y cubed, all to the third power, times x to the negative third raised to the second. So I can use the power property here a ton. So I got the 3 here. I'm going to distribute it. 2 to the third power is 8, right? Because it's not 6, but 8. 2 times 2 times 2, right? Then we got x cubed to the third power is going to be x to the ninth. Then we got y to the third power raised to the third power is y to the ninth. So I just finished this section. Now I could bring this in. X to the negative 3 raised to the second power is going to be x to the negative 6th power. Okay? That's just the whole numerator. I just kind of simplified it. I still have this denominator I want to bring down, so I'm going to bring that down. Okay? I got a bunch of negatives in there. That's going to be easy. All I just need to do is move some stuff around. Okay? So the 8 I could keep in the numerator, x to the ninth, y to the ninth, keep in the numerator. I'm going to bring down these. I'm going to put those on the top, okay? Oh, sorry. Just made a mistake here. Okay, so I'm bringing that up to the top, y squared up to the top now with a positive exponent. This x to the negative 6, I'm going to bring that to the bottom with a positive exponent, okay? So now I'm going to start canceling. I know that x to the 6th, I can cancel out and leave that as 1 and take 6 from the top, leaving just 3 there. Make sense? Then I got the rest of the problem I can start simplifying. We got bring down the 8. We got x cubed, y to the ninth, x squared, y squared. Okay? The denominator is 1, so I don't need to worry about bringing in that. Now I know it's just the numerator that I'm worrying about. So now I'm going to bring down the 8. I'm going to combine the x's. X cubed times x squared is x to the 5th. Y, oh boy, went too fast there. Y to the 9th times y squared is going to be y to the 11th. And that's it. We're done. Okay? So the big idea, work in sections. Numerator first, denominator. When everything starts simplifying, then you can work it out more easily. Okay? No writing right now. Let's go back to the ones, since ones had the easy one earlier. Ones are talking about... Ones raise your hands. Ones are raising their hands. Ones are talking about number 1. And threes raise your hand. Threes are talking about number 2. Okay, ones and threes are talking. Ready, set, and go. Raise your hand if you need more time. Okay, I'm going to give you 30 more seconds, okay? All right, so number 3. Number 3, start this one off by yourself. We're going to start really easy and start building our way up, okay? So you got b to the 4th raised to the 5th, okay? I'll give you 15 seconds to do this. So on number 3, you should have had b to the 20th power, okay? Feels pretty good. Turn to your neighbors, tell them if you got it right or wrong. If you don't erase it, don't erase it. Don't erase it. Pick up your board. Okay, then don't erase it. Don't erase it. Sorry, you gotta wait till I tell you to, okay? After we're done explaining it, then you can erase it. Okay, you explain it. Thank you. Erase it. I really need you kids to focus on following that direction. Okay, next one, number 4. I'll start us off. We got 4 to the 1st. Kind of give you all the answers now. Okay? There you go. 4. B to the 4th, C to the 3rd, all raised to the 6th power. Go. 4 to the 1st raised to the 6th is 4 to the 6th. B to the 4th raised to the 6th is B to the 24th. C to the 3rd raised to the 6th is C to the 18th. Then you multiply out 4 to the 6th and you get 4,096 B to the 24th. Do not erase your boards. If you did it right, show your group. If you did it wrong, show them where you made a mistake and explain how you should have fixed it. Ready, set, go. Do not erase your boards. Okay, stay after class. 1 minute. If you erase your board, you stay after class. No, I did not. I kept saying, okay?
I know you said don't. I wasn't really listening.
So you had a wrong answer, and I knew that.
I had it wrong.
Now you lost, solve it out. So explain how you did it.
I didn't solve it all the way out.
Well, what are you going to do better next time?
Solve it all the way out.
Actually, I had a different mistake that I saw in there. Yep. See why we don't erase our boards? So now let's stay after class 2. Why don't we do it in the 2 minutes for you? I don't need you picking on other people. Yeah. Thank you. I'm not trying to be mean. I need a structure here. There's important things we're missing out right now. Okay? Does that make sense?
Yeah.
Okay, good. Okay, now that we're done explaining it, now you can erase for it. Okay? Thank you. Okay, next one. Eyes up here. V to the negative second raised to... Okay, ending your conversations. Next one, number 5. V to the negative second, all over 2u squared, all raised to the third. Okay? So just to help you out, remind you, you just distribute v to the negative second raised to the third. You just multiply. What's negative 2 times 3? Good. So now finish up the problem, okay? Remember what negative exponents do. Think about that. Working by yourself. On number 5, we got v to the negative 6, right? Do we like a negative exponent?
No.
No, so take the v to the negative 6. Let's bring it down, okay? And make it positive. What happens to my numerator? It just turns into a 1. That's it. So there's your answer. Yes. Shh. Question was, how do we get an 8? We have to raise 2 to the third power, right? Because this is like 2 to the first. What's 2 times 2 times 2? 8. Does it make sense? Question? Yes? Don't erase your board, Ashley. Otherwise you stay with me at your regular lunch. Yep. Yeah, it does. What happens if you left this on the top? Is this supposed to be in the numerator at all? No, it'd be wrong. Okay, do not erase your boards. Now it's show and tell. Show them if you made a mistake. Show them how you're going to fix it. If you got it right, show them that you got it right. Explain how you could fix it, okay? You were so close. All you have to do is move that, right?
I don't know. I thought it was fine. I thought he was okay up there. He looked alright.
Yeah. Do we like negative exponents, though? Remember the notes, the first square. We don't like negative exponents. Yes.
If you're bringing the negative to the bottom, why can't it just be that without the 1 on? Do you understand what I'm saying?
Because it has to be on the denominator, and when there's nothing left, like we're basically saying we're dividing both sides by negative 6, so then it goes to the bottom.
Oh, that's what you do.
Yeah, the 1 on top. So you were so close. All you have to do is just draw a, because you did it right. You just forgot to put the 1 on the top, right? Oh, you forgot to do the 8 too. Yeah, you're so close though. That was good. Look at you. You're doing math. Yay. Okay, next one. Number 6. Erase your boards. Yes, thank you. Good job. Now you don't have to stay a minute after class because you reminded me. Erase your boards. You just won your time back. You still have to wait.
Hey, don't laugh.
Thank you. Keep her in check, okay? Good. Okay. What? Do you want another minute with me? Okay, number 6, question. What's anything to the 0 power? 1. So be careful. Watch up here. Watch up here. M to the 0 is the only thing that you could change to 1. Everything else stays there. Okay, so we have 2 to the 1, right? That's still all there. But the only thing that's to the 0 power is M, which is equal to 1. Do the rest of the problem. Go. Just M to the 0 is equal to 1. So that's the one you ignore. Everything else, start working it out. Okay, so these last 2 problems we didn't get to in class, but I wanted to show you how to do it. On number 7, the first thing you want to do is you want to just focus on the numerator. Okay, so as we focus on the numerator, I notice it's a to the 4th, b to the negative 1st times 2, a to the 3rd, b to the 4th. So the first thing I want to do is I notice that there should be a coefficient that there's not. We could assume it's 1. So 1 times 2 is going to be 2. Then we have a to the 4th times a to the 3rd is a to the 7th. Okay. Then we have b to the negative 1st times b to the 4th. We're going to add them, is going to be b to the 3rd. Then we bring down 1 times 2 is 2. Then we're going to focus on the denominator. I'm going to bring that down. I can't simplify it, but I'm just going to leave it there and see what I could work with. So 2 and 4, I know that are like a fraction. I can simplify it as 1/2, right? Then a to the 7th and a to the 4th. I know a to the 4th is smaller. I could cancel all those out and take away 4 from the numerator, leaving a to the 3rd. Then the b to the thirds, they're both the same, so I could cancel both those out. So really what I'm left with is 1 times a to the third all over 2, and that's it. Another way you could write it is 1/2 a to the third. Okay, so that's the answer for number 7. Alright? Number 8, I'd like you to try it on your own first before we write it down. Here it is for you. So please pause the video and do it by yourself, and then when you're done, press play. Alright, you should be done now. So this is what I would do. I'm noticing that the numerator is much more simplified than the denominator, so I'm going to hide the numerator first. I'm going to focus on the denominator. So we have 2x cubed y to the 4th. I'm bringing that down because I know that I can't really do anything with this term, but over here on the bottom right I can, right? I got this 4 here that I could simplify. So I'm going to distribute that across. So 2 to the 4th power is going to be 2 times 2 times 2 times 2, which is 16. Then we got y raised to the 4th power is going to be y to the 4th. X to the negative 1st raised to the 4th power is x to the negative 4th. Okay? So then it's x to the negative 4th. Then I have the rest of the problem in the numerator I want to bring down. I don't want to forget about that. Okay? So I got some issues here. I got this negative y to the 3rd, or negative 3, and this x to the negative 4th. I want to deal with that. I could do some simplifying right now. This x I could cancel out with one of the x's down here, leaving x squared in the denominator. Okay, the x to the negative 4th, I'm going to bring to the numerator. And then I also notice that there's y to the negative 4th. So I'm going to bring the rest of the problem down. So we got 2 times 16 is 32. Right? 32 I got by multiplying 2 times 16. Then I have x to the x squared. I'm going to bring that down. Then we have y to the 4th. We're bringing that, and we're going to multiply these two y to the 4th together to get y to the 8th. And then we have x to the negative 4th. We want to bring that up to the top. And we have the y to the negative 3rd. We brought that down here. Okay? Now we have this x squared. I'm going to simplify, cancel that out, take 2 off the top, so we have x squared left. And we have x squared all over 32 times y to the 8th times y to the 3rd, which is y to the 11th. Can't simplify anymore, so that's my answer. Okay? So that's the conclusion of the lesson. Check where you're at. That was the hardest problem. And then work out the problems, check your answers, and be sure you have questions if you have any. We'll work on them tomorrow.